Okay, so now that we can look at a function and identify what is A, what is B, what is C, what is D, now we're going to actually look at some functions and we're going to figure out what do these things do, right? We start off with the parent function. We know what the parent function looks like. If I put a plus 5 on the outside, what does that do? If I put a times 2 on the inside, what does that do? Right, so we want to look at each of these letters and we're going to figure out what they do, and we're going to do them a little bit out of order. So we're going to start off with D, right? When we looked again at our generic function, we had a plus D that was at the end. So we're going to actually take a look at a function, and here it is. Okay, my my squared function, and I'm going to say, well, what does this do, right? So if you take a look up here, I have that same general form A, B, C, and D, and I replace the f of x, the f on the in the generic function, with squared. I'm saying the function that I want to use is squared. So what we're going to do is we're going to leave everything else alone, right? This is my parent function right at 0, right? I have zeros for C and D, so they would disappear, and I have ones for A and B, so they would disappear as well, right? And what I'm going to do is I'm just going to change the D value. I'm going to say, what happens if I change the D value from 0 and I start it increasing? And if you notice, it's just going straight up and down, right? So we can take a look and say, as this D value is changing and it's becoming, like, for example, in this case, it's now D is plus 1, or D is plus 2.2, or D is plus 3, you can see that the graph is sliding up. When I make it negative, the D is sliding down, right? So what we can say, if I make the graph disappear, well, what does D do? It looks like D makes the graph vertically slide up or down, right? So it's a movement up if it's positive, if it's movement down if it's negative, okay? So I'm not going to stop, and I'm not going to give you time to write it down. You can hit the pause button and you can write things down as we go. We're just going to keep moving, and we're going to say, now let's take a look at another one. What does A do? Okay, so we're going to go back to my graph. So I'm going to put the D back to 0. We're going to pretend like it's not there anymore. Okay, and we're going to say, well, what happens when I change A, right? How does that move things? Okay, so this is actually going to do two things. Let's start with the first one. Right now A is 1, which means we wouldn't see it. We don't usually see 1 values when they're being multiplied. Okay, I'm making it slightly bigger, right? It's getting bigger. And if you notice, what's happening is my parabola is getting skinnier and skinnier and skinnier. And now I'm at 10, and it's as skinny as it's going to go. If I made it bigger, it would get even skinnier, okay? So that's one thing, is it could make the graph look skinnier. So now I'm going to slowly move it between 0 and 1, right? So here's 1. If I move it down to 0.9, it got a little wider. 0.7, it's a little bit wider. 0.1, it's way wider, right? So things between 0 and 1, fractions and decimals between 0 and 1, are making my graph get wider. And I can make this smaller and smaller. If I didn't want to do 0.1, I could say 0.01 or 0.0001, and it would get even wider. Right? So it looks like A is taking my graph and it's making it skinnier as the number gets bigger. It's getting wider when I have fractions and decimals. So here's the thing. I didn't talk about anything on this side. If you notice, it's doing something else. If I take a look at negative 0.1 and I compare that to positive 0.1, it's the same graph, except it's flipped over the x-axis, right? So making the A value negative, right? Here's your negative 0.10, and here's your positive 0.10. It's this, I'm sorry, negative 10 and positive 10. So positive 10 is above the x-axis. It's an open up parabola. When I go to negative 10, it's the exact same skinny and wide, but instead it's flipped over and it's going down, right? So A is actually doing two things. It's dealing with how narrow or wide the graph gets, and positive and negative determines whether it's going to be a parabola or it's going to flip it upside down. It's going to reflect it over the x-axis. Okay, so let's go back to our notes and kind of formally say, well, what does A do? It looks like A is going to vertically stretch the graph, right? So it's going to make it skinny, or it's going to make it wide. And if A becomes negative, the parent function is going to reflect over the x-axis. That should be, it says y-axis on my screen, but let's say that it's going to reflect over the x-axis. It's going to go from the top of the graph down to the bottom of the graph. Okay, so it's doing two things we have to watch out for A. Okay, let's keep going. Let's talk about what happens for C. So again, let's take a look at that generic function. All right, we'll fix our original function. We're going to make A. Oh, let me get there. Okay, we're going to make A 1 again, make that look kind of nice, and I have my parent function again. So if you notice where C is adding or subtracting, but it's inside the squared, right? So it's being squared. The function is acting on it. So here's what this does. If I make this one positive C, it looks like it's sliding to the right. And if I make it negative C, it looks like it's moving to the left. But the size of the graph is not changing, right? My function is not getting skinnier. It's not getting narrower. It's not doing any reflecting. It's strictly sliding. So if you notice, C is acting a lot like D. D is not changing the shape. It's just sliding up and down. C is doing the same thing, but it's moving it left and right. Okay, so that's what we're going to say about my C value. We're going to say, well, what does C do? It looks like C is going to move my graph horizontally sliding left and right. Okay, and I'm giving you that little note that we talked about in the last video when we're identifying. Be careful. The value of C is what's determining its direction, not what you see in the function. So if I see x minus 3, I'm going to say, well, that makes my C value 3. So it's going to move 3 units in the positive direction. If I see x plus 3, well, I'm going to say, well, to make the graph turn into plus, I had to make my C value negative 3, and it's going to move towards the negative numbers. Okay, so when we try out some of these problems, keep that in your mind. It's what the value of C is, not just what you're seeing when you take a look at the function. Okay, so here's the last one. Okay, what does B do? B is inside of the function. Right, here's what it's going to be. Let's just see it happen. Right, so when I'm taking a look at my graph, I'm going to say, all right, B is 1. B is kind of doing the same thing that C's doing, right? It's making it, I'm sorry, that A's doing. When we were talking about A, we said it makes it get really skinny when it gets to be a big number, right? If I go to fractions and decimals between 0 and 1, it's getting really wide. But here's the thing. When I'm going to negative, it didn't flip. What happened there, right? So that's what we have to figure out is how does the negative affect it? So let me move this over, okay, back to my parent function, or really close to it, even if it's not exact, okay? And we're going to say, well, what happens when this is negative, right? So positive 10 and negative 10 look very similar to each other, right? So here's what ends up happening. We're actually doing a reflection, but the reflection is over the y-axis instead of being over the x-axis, and we can't tell the difference in this one because it's symmetrical. So let me show you a different function. I'm going to replace this one with x cubed. Okay, so this is the x cubed function. All right, and again, all the other stuff still happens, right? Skinny and reflections and all that kind of stuff's happening. But when and here's your slide up, your slide to the right and to the left, and your slide up and down. All that stuff still happening to this function, right? But here's what ends up happening with this function, and we'll be able to see it better. If you notice, my tail is on the right, is going up, and my tail on the left is going down. If I go to the negatives, it switches, right? So it's actually doing a reflection over the y-axis, and we can see that happening with this function. With the squared function, we couldn't. Okay, so it's the same idea as A, where it's doing a reflection. Right here, my reflection is going up and down, right? With when I'm talking about B, my reflection is actually, it kind of looks the same, but it's going left and right instead. Okay, so it's a horizontal flip instead of a vertical flip. Right, so if I go back, B is horizontally stretching and shrinking the graph, and it also does a reflection. Apparently my functions were backwards. B is going to do a reflection, but over the over the y-axis. Okay, so B is negative. The parent function reflects over the y-axis. So that's a little change based on what you're seeing and based on what I'm saying. B should do when B becomes negative, it does a reflection over the y-axis. Okay, so we have 2 changes happening there. Okay, so now that we know what all these things are, we're going to actually look at a problem, and we're going to say, let's figure out what it does. Okay, so here's some functions. So what I'm asking you to do here is I'm saying, make a list, just using words, of all the functions, all the changes that are happening to the parent function. So we're going to start off with an absolute value. Let's identify the letters. Okay, and in this case, I'm going to say, here's an A value, and I know it's A because it's outside of the absolute value bars, right? A and D are outside, okay? And so I'm going to say, here's A and here's D. B and C were the things that happen on the inside, right? So I can say over in number 2, there's some stuff happening on the inside of the squared. I don't have anything happening on the inside of the absolute value. So I'm saying A is being multiplied, D is being added, those are the values. So here's what's going to end up happening. My A value, okay, I'm going to say is going to, remember we said as A gets bigger, it makes the graph shrink, get narrower by a factor of 2. So A makes my graph get narrower, okay, narrow by, and what we say is a factor of 2, right? So that's going to say how much narrower is it getting. If I had a 10 there, I would say it's getting narrower by a factor of 10, or if it's 5, it's getting narrower by a factor of 5, okay? And I can say the same thing with D. I can say D is going to make it slide up by 4 units. Okay? And so that's a transformation up by 4 units. And we can do that for each of these problems. I can take a look at the second one and say, okay, it looks like I have an A value, this is a C value, this is a D value, right? Based on the way we were identifying them before. So let's go in order. I'm going to say A. Okay, A is actually going to do two things. It's going to get narrow, right? The original parabola is going to get narrow by a factor of 5. Excuse my writing. Okay. A is also going to do something else. It's going to reflect it, because it's negative, over the x-axis. Okay? It's going to go from the top of the graph down to the bottom of the graph. Okay? My C, okay, is going to move it. So my C value is 4, because my minus sign didn't change, so C value is 4. That means that C is going to move in the positive direction by 4, which is to the right. So it's a right by 4, which if you don't write 4 units, not a big deal. Right by 4. Right? And then I can say that the D value is a negative 1, which means D is going to make it move down, okay, by 1. Okay? And I can do that for each of these functions. I can describe those changes. So for these first two problems, let's talk about domain and range. Okay? So the domain for my absolute value function, something that you would have seen, if I draw my parent function, it's kind of very similar to the parabolas that we've seen. It's just a V shape. Okay? So I would say my original parent function's domain was all real numbers, okay? And my range for my original one was y is greater than or equal to 0. It goes from 0 and up. Okay, so when I'm talking about the domain of and the range of this new function, I'm kind of picturing in my head that this thing's got a little bit narrower and it's moved up by 4 units. So here's how things would change. The domain wouldn't change at all. I've covered everything already, so my domain is still all real numbers. But my range, since I slid it up by 4 units, the bottom of this graph is no longer at 0. It's up here a little bit at 4. So I'm going to change my range and say y is greater than or equal to 4. And I know that because my D value moved the whole graph up 4 units. So the bottom of the graph, where it turns around and starts heading the other direction, is now up at 4. Okay, I can do the same thing with the second function. We know the domain and the range of the parabola. It's very similar to this one, except it's a curved U shape instead of the V. So it starts off with the same domain and range. The domain is all real numbers. The range is greater than or equal to 0. So when I take a look at this, I'm going to say, okay, let me picture in my head how this has changed. Right? So it started off as a U shape. It slid 4 to the right, down by 1, got a little bit narrower, and flipped over. So let me think about my domain. And if we want to picture this, kind of sketch it, what happened, okay, we're going to say it is kind of over a little bit and down a little bit and upside down. So my parabola would be something like this. Okay, and it's not working. Oh, there we go. My thing is having a little bit of difficulty. So it'd be kind of like over here a little bit, and I'd get this upside down parabola. So if I'm trying to describe that, I would say, okay, it looks like it's to the right, but that didn't really change the domain. The domain was everything to start off with, so the domain is still everything. So I'm going to say that my domain, and again, I'm having some difficulty with my pen here. Let me make that stuff go away. Okay, my domain is still going to be everything. My range, I'm going to say it moved to the right, and it moved down, okay, and it flipped over, so that's going to change things. Okay, and I'm having some issue with my graph again. Okay, so I'm going to say my domain, sorry about that, all real numbers. My range is going to be y is less than or equal to -1. It slid over, I'm sorry, and that didn't change anything. It slid down, so now the top of the graph is at -1, and you can see that it's covering everything from -1 down. Right, so we're going to hopefully start picturing these things in our head as we go. Right, so I'm going to show you the next two, right? And I'm going to let you try these ones out. Okay, so here are two more. This is a cubic function and a square root function. And all I want you to do, don't worry about domain and range, is describe the changes that are happening. The sliding to the left and the right, the sliding up and down, any narrowing, any reflecting. Just make a list in words of all of those things.